we're going to take a look at a couple application problems, how we might use a rational function to model some real life situations. And later on we'll look at a lot more of these real world problems, and we'll look at how, when we're studying solving rational equations. For now we're just going to look at a few situations that might lend themselves to this type of function. So in example A, Mary and some of her friends are thinking about renting a car while staying at a beach resort for a vacation. Boy, that really sounds nice right now with the snow falling and cold temperatures. But the cost per person for staying at the beach resort is $300. So that's the cost per person for staying at the beach resort is $300. And the cost of the car rental is $220. So they rent a car, they're going to drive down and stay at the beach resort. If the friends agree to share the cost of the car rental, what is the minimum number of people who must go on the trip so that the total cost for each person is no more than $350? So let P be the number of people who agree to go on the trip, and let C of P be the cost in dollars for each person. So when we think about the thing that we already know that's per person already, that has already been accounted for, that each person has to pay, is $300. They can avoid that. So if you think about this little function we have set up here, we have something that's going to be divided by the number of people. That's actually the car rental. So that car rental, $220, is going to be split by the number of people that are going. So the more people that go, the less the portion is that each person pays for renting the car. So this is for the car rental, right? And then for the resort, to stay there, it doesn't matter how many people go, everybody has to pay $300 a piece. So this is that aspect of a rational function, whereas the P increases, okay, because it's a denominator. As that increases, then the price, in this case the cost to go on this trip, is going to decrease because this first factor this first part of the function is going to go down as P goes up. So that's going to be our function, and say we wanted to graph this function, we could pick some specific number of people that might go, and then what the cost would be. So for instance, let's say only one person ends up going. It's not much of a friend trip, right? So it's supposed to be a friend trip. But if one person went, then they'd have to pay for the entire rental car, and so that would be $220 plus $300, which would be $520. So that's if only one person goes. If two people go, they're each going to have to split that $220, so that would be $110 each, plus $300, which would be $410. If three people go, I could figure out that. It's not a nice number. I don't have my calculator, but I'm going to pick another one. So let's say 4. Let's see, 4 would go in there, 55 times. So that would be 55 and 300. That would be 355. And they wanted it to be person to be no more than 350, so we're not quite there. So if we went up to 5 or 6 or whatever, so I broke down and got my calculator out, and if 5 people went, it would be $344. If 6 people went, it's $336.67, and so on. So let's say I started to plot out some of these points. At one person goes, $520, maybe right there. 2 people go, it's $410, so maybe just above $400 right there. And I skipped over 3, but there's if 4 people went, that'd be $355. And at 5, it's going to drop below that $350 mark. So at 5, it was $344, so then that's going to be just a little below that. And if you think about in terms of what these graphs that we've been looking at, that 300 right here actually represents the horizontal asymptote, because if you think about it, we're never going to be able to get below that if we're going on this trip, because we at least, no matter how many people we decide to bring and stuff in that rental car, like it's a clown car or something, we're still going to have to pay that $300 in a fraction of whatever the car rental. So the bigger that number gets, the less we'll have to contribute towards the rental car, but it'll never drop below 300. And so what's eventually going to happen is this graph is going to kind of level out, get closer and closer to that line at 300. So that's that real life aspect that is modeled by a horizontal asymptote. Now on the other side, let's see, it's gonna start to kind of go increasing towards the y-axis, because like imagine if you could have just a half a person went. So in theory you couldn't really do that, but if so, that would actually mean the 220 divided by a half, that would be 440, and 440 and 300 is 740. So like if a half a person went, you'd be up here at 740 and so on. So this would start to kind of extend out and up, and you would see that characteristic hyperbola shape. But we're only going to see the one branch because in these real life situations, some of these, just negative input values would not make sense. So that's what your graph would look like, and that would model all the different possibilities. So the further out to the right you get, the closer you get to $300. The further and closer to zero, the higher that price. In theory, if you could have, less than one person renting the car, then that just increases the amount that's paid towards that. So there's an example of a real life application there. In this next example, so Justin has purchased a basic silk screening kit for applying designs to fabric. The kit costs $200, so he has to dole out the $200 for the kit, right? He plans to buy t-shirts for $10 each, apply a design that he creates to them, and then sell them. Model the situation with a rational function that gives the average cost of a silkscreen t-shirt when the cost of the kit is included in the calculation. So, in other words, he's got to buy the kit, and then he's got to pay $10 per t-shirt. So, each of the shirts, a part of the actual cost for that shirt is going to be the original cost of that screen kit. So, that $200, the part that's going to be added to the $10 for the t-shirt is going to be whatever fraction it is that is going to be applied to each shirt. So that would be however many shirts S, you could take that $200 kit and distribute it over the number of shirts that you buy. So let's say you buy 10 shirts, right? Well, 200 divided by 10 is 20. So $20 of that 200 is going to be sort of like charged to the one shirt, right? And then plus another $10 to actually buy the shirt. So that would actually make each shirt $30, okay? So then let's say instead you buy 20, okay? Then 20 shirts, divide the original $200 kit by 20, that's $10, but then the cost of the shirt is actually $10, so that makes each shirt cost $20. So of course, as the number of shirts you purchase goes up, the per t-shirt cost is going down. So that's why they always give these big discounts for buying in bulk. So the cost, C, is based on the number of shirts. Cost per shirt is really based on how many shirts you purchase, because, again, then the amount that you're paying towards each shirt from the kit is diminished each time you increase. So this would be a function similar to the last one we wrote. And the question is, we want to know what would bring the cost below $17.50. So you could make a table of values. You could graph it, and you could pick some nice numbers, or you could use a calculator and that's what I'm going to do real quick. I'm going to type it in. So if I end up making only one shirt, that shirt's going to cost me $210. If I make two shirts, okay, then I can split that $200 to each shirt, and each shirt would be $100 plus 10, so 110. So we jump up and say 5, we make 5 shirts. So then 200 divided by 5 is 40 plus 1. That makes each shirt $50. Okay, we want to get up there quick because each shirt's going to not really get down to where it's a reasonable amount until we get, quite a ways down. So let's say we jumped up to, I don't know, 20 shirts. We already talked a little bit about that. If we did 20, 200 divided by 20 is 10, plus 10 is $20. Each shirt would cost $20. Say we did, it's another good number. I'm looking at my calculator for some good numbers. At 40, 200 divided by 40 would be 5, plus 10 is 15. And now we've dropped below that 1750, which is what we're trying to find out. So plotting this graph, so where the 5 would have been, it's way up there. At 10, it would be for 10, it would be, hold on just a second. If I made 10 shirts, each would average $30. If I made 20, they'd be $20. And if I made 40, it'd be 15. So we're talking right there now. But now we've dropped below. So the lowest that could possibly be is if we thought about, if we had bought an infinite number of shirts, then that 200 would be divided by this really, really, really large number, right? So only just a very tiny bit is going to be charged to each shirt, right? And then plus the $10. So the lowest you could possibly get is just above $10. So that $10 ends up being that horizontal asymptote. You can't drop below that. It'll never get less than $10 per t-shirt. And then on the other end, of course, it's just going to keep going up and up, because if you made like one shirt, that full $200 would go towards each shirt, so that'd be $210. So the closer you get into zero, the higher that price is going to shoot up there, so you get that look. So again, to kind of answer the question, I guess, really, we sort of are a little ahead of just graphing. We're really solving an equation if we said we want to know when it dropped below 1750, but what we could do is put that 1750 in, and I could have done that with the last question too, in for the cost, and I could solve this in this way. So if I subtracted the 10, if I want to solve for S, I subtract the 10, that makes 750 equals 200 over S, and then you could do the cross products, which would make 200 divided by 750, and that's going to be, if we got to about 26.67 shirts, so about 27 shirts, and that would make the per shirt cost drop below 1750. Okay, so that actually does it for second part of the lesson. And now you can kind of see where we might maybe go back and see if you can solve this one and answer when the trip would cost no more than $350. Similarly, how we just did this last one. So plugging in $350 for the cost and solving. But just keeping in mind that these real life situations, many times you have to either round up or round down based on, with this one we wanted the cost to be no more than $350, so you'd have to round up the number of people. So anyway, that does it for the lesson. Thanks for coming.